go to the geoelectric model. We do mostly have calmer conditions this morning, but there are also flashes of intensified current here in just the last few hours. The solar wind began dying down almost a day ago, and the geomagnetic storm conditions faded throughout the day. So what's the cause of the currents this morning? This is where we recall that the energy first affects the highest layers, begins inducing current. But even after that induction ceases, the energy from the top continues downward through the Earth capacitor, and that happened last night and continues this morning. Top earthquake of the last day struck the Philippines. That's at Blot Echo depth and with a typhoon offshore. Taking us to some weather notes, starting with Taiwan, where that very same typhoon is expected to tear across the northern part of the territory before tracing further northward towards China. While the system skirts the coastline, there will be isolated severe conditions, but then the eastward pull sets in, and a direct hit to South Korea would be a very unwelcome sight, would be their second big impact this month. Quick look at the Midwest states and the ongoing flooding, and no, there's more coming. But the low cell sitting over the Rockies is doing much more than just rainmaking. When we see the wind flow into the low cell, it is clear why the temperature forecast is what it is. Searing heat in the center, record cold and record snow for parts of the Rockies. So folks, lightning across the planet reacts to forebush decreases. Question 1, how does it react? Well, when a forebush decrease occurs, lightning frequency goes down across the globe. Question 2, what is a forebush decrease? Well, that is a very non-descriptive name for something that happens to cosmic rays, high-energy atomic nuclei from distant supernova and other huge cosmic events. They come into the atmosphere and break out as particle cascades known to strongly affect cloud production, atmospheric ionization, hail nucleation, and lightning. When Earth gets hit with a plasma shockwave from the sun, that electromagnetic particle plasma cloud acts to block out cosmic rays from the rest of the galaxy, causing a drop in the cosmic rays that they call a forebush decrease. This causes a significant drop in the atmospheric ionization, particle injection, cloud nucleation, and more, leading to the drop in lightning. This is indeed one of the better solar forcing papers of the year. Let's go out from Earth next to a stellar system that might just have an Earth of its own. In this system, it's got both a Mercury and Venus-like planet, just like we do in our system.